Welcome to Graphing Linear Equations. We can use a variety of different methods to graph a linear equation on a coordinate plane. And these are the three that we're going to focus on today. We can graph if we're given 2 points. We can graph if we're given 1 point and then the slope, or if we're given an equation. And I'm going to show you how, going through those examples. Graphing an equation given 2 points. So if we're given 2 points here, the example below, -3, 3, all right, so -3, 3, and 3, -1, so I go over 3 and then down 1. Those are the 2 points, and I would draw a line straight through them. Let's pick another point. We can do this almost anywhere. How about we'll start with 4, 2, so I'd go here, 1, 2, 3, 4, up 2. We can all agree that is the point 4, 2. And let's pick another point. How about 0, 3? That's easy. Start at 0, go up 3. We got 0, 3. So that would be 0, 3, and this one 4, 2. Now I can draw a straight line. Let's see if I can. Should look something like this. I decided to just go get a straight line from somewhere else instead of having to draw it. But through those 2 points, we have a new straight line. Remember, we want that line to extend because that line is not just contained to this small segment. That line goes on forever. This is through the line 0, 3, and 4, 2, but we can look there for other points along the way to help us identify other points down the road. Shouldn't be too bad there plotting from 2 given points. Let's do another example here with an equation, graph the equation with an x-intercept of, with an x-intercept of 7 and a y-intercept of 3. All right, so if an x-intercept, that means that when y is 0, x is 7. Remember, x, y. And a y-intercept of 3 means that x is 0 and y is 3. So let's go with, we have our y here, x here, 7, 0, 1, 2, 3, 4, 5, 6, 7, 0 should be right about there. And 0, 3, start in the middle at the origin, 1, 2, 3, and we have 0, 3. From here, we should be able to draw a straight line. Let's see if I can do it. That's not bad. And that line extends both ways there. I would recommend, if you're doing this on a computer or anything like that, actually getting a straight line function. Most apps have it. Mine does not right now. So there we go. We found 2 points and we drew a straight line. And we have now graphed that equation, even without knowing any of the other information. A little bit more work to do here, graphing an equation given a point and a slope. To graph, we're going to plot the point and use the slope to plot another point. So we'll eventually get to 2 points. Here we have a given point, 3, 2. We go over 1, 2, 3, up 2, should be right there. Good. Now, to create a line that's straight, we're going to need to use what we have, which is the slope. Our slope is 3. We can also call that 3 over 1. Remember that slope is our rise over our run. Hopefully you remember that from another class. Rise over run. So if I start here at 3, 2, I would rise 3, 1, 2, 3, and run 1. There is one more point that we know has to be on this line because we're already given the slope. Another equivalent here, just to show another one, would be -3 over -1. A negative divided by a negative is positive, but we can also rise and run -3, -1, 1, 2, 3 down, and 3, 1 to the left to plot another point. Especially now that I have 3 distinct points, I should be able to draw a pretty good line extending upwards, and this obviously is going to keep going. So only given 1 point and the slope, I was able to graph this equation. Let's take a look at another example. Graph the equation that contains 2, 3 with a slope of -3/4. Let's start by finding our first point. We start at the origin, and our x value moves us to the right 2 and up 3. It's going to be right there. Again, we're given a slope here. M equals -3/4. Our rise is -3, and our run is +4. -3 down, 1, 2, 3, and to the right 4, 1, 2, 3, 4. Should have followed me here. Looks like the point's about 1, 2, 3, 4, 5, 6, 0. And that matches up pretty well there. We can also go the other way, right? These would be equivalent to each other. 4 over -3. Oh my goodness. Not that. Don't do that. I made that the reciprocal. 3 over -4 would be the same slope. So our rise would be +3 and our run would be -4. So 4 to the left, right? So if we rise 3, 1, 2, 3, and we go to the left 4, 1, 2, 3, 4, our straight line continues. I can do that again. 1, 2, 3, 1, 2, 3, 4. From there, I'm pretty sure I can make a decently straight line. I got lots of points to go to, and this line extends for the rest of history. Here, I have graphed an equation that contains 2, 3 with a slope of -3/4. Now we're going to look at graphing when given just an equation. And this is the equation we're going to work with down here. All right. I'm going to work with this right here. Y equals 1/2 x plus 4. We want to put the equation in slope-intercept form. So we always want to do first. Check. It is in slope-intercept form that y equals mx plus b. I want to plot the y-intercept. So if x equals 0 here, 1/2 times 0 is 0. So y would equal 4. 0, 4. I can do that right there. 0, 4. Check. Use the slope to plot a second point. I have positive 1/2 as my m value. That could also be -1 over -2. Those are equivalent. So let's start with the positive one. My rise over run, rise 1 over 2, rise 1 over 2. I could also do it with this slope, -1 down, -2 left, -1 down, -2 left. Now I'm going to draw a line through those points as straight as I can. Goes even off the graph there. Here I have graphed when given just an equation. I've put the line on the graph here. Anything that's going to be true with this equation is going to be true on my graph. Here, I'm going to graph 4x plus 5y equals 15. I've got to go back to my checkpoint there. What do I do first? I want to put it into slope-intercept form, that y equals mx plus b. So I need to do a little solving first. 4x plus 5y equals 15. For slope-intercept form, I'm trying to solve for the y. That's my goal. I need to do that by moving the 4x first. I'm going to subtract 4x from both sides. 5y equals -4x, I like putting the x first, plus 15, because it stays in my mx plus b. Next, I need to divide both sides by 5, and I have to do it to each of these things, leaving me here with y equals -4/5 times x plus 15 divided by 5 is 3. There we go. That's my slope-intercept form. I'm feeling better about that already. Now I need to find my y-intercept. If x were equal to 0, what would y equal? Well, -4/5 times 0 is 0. So y would equal 3. If x is 0, y is 3. 0, comma 3 for my first point. Now I'll need to plot some other points. I have negative 4/5 as my slope. It could also be 4 over negative 5. Let's do this first one first, negative 4/5. My rise is going to be down 4. 1, 2, 3, 4. And to the right, 5, because it's positive. 1, 2, 3, 4, 5 is my big point there. Let's use the other one from the first point, 0, comma 3, to make a third point. I'm going to rise 4. 1, 2, 3, 4. And to the left, 5, because it's negative 5. 1, 2, 3, 4, 5. From there, I have 3 solid points. I should be able to draw a straight line that continues for a long, long time. Oh, that's bad pardon at the end. That was bad. Now, I have graph 4x plus 5y equals 15. A reminder for your slope, if you have negative 4, that means it's going to move down. If you have positive 5 in the denominator, that's to the right. If you have positive 4 in the numerator, that's up. And negative 5 in the denominator, negative means it's going to go left. Just a little hint for you there. All right, let's see how you do. Go to Schoology and do the try it problem there. See you in class.